YouTube and Facebook. Okay, good morning, everyone. And today is February 8th of 2020. That sounds like such a futuristic date. It's already here, right? And why is it we haven't figured out a lot of things in physics, even as of this late date? So we've got a couple people in our live room here, and we've got Bill Lucas. So, Bill, I just wanted to ask you. So, considering our space age date, why is it that we seem to have so many holes in physics that seem to be needing to be filled?
It has a lot to do, unfortunately, with other things outside of physics. It has to do with, uh, for instance, the history of our country. We have in the days of Thomas Jefferson and James Madison, um, the each of the colonies had an established church, and this church was different from one colony to another. For instance, Maryland was Catholic, Virginia was Episcopalian or Anglican, Massachusetts was uh, Congregational Church, and but then we had a series of reformations, revivals, and that sort of thing, which created a large number of churches, and they became bigger than the established churches. So these were Baptist, Methodist, Presbyterian type churches. And so when we were forming the United States, James Madison and Thomas Jefferson uh, set up a wall of separation between church and state. And there were people who didn't like the reformations that were going on, the revivals. They didn't like the established churches, etc. And so there were three parties that they were dealing with, and this establishment of all separation of church and state helped them. But starting from about 1850, this wall of separation was used so that the people representing the government could adopt science that was opposing all religious things. So uh, if you look at the scientific theories developed, none of them agree with the Bible. You have the theory of evolution, you have the Big Bang, you have the age of the universe is billions of years, not
But
thousands.
I think all of those are, say, relatively recent, right?
Well,
Because you're
they
going
started in
back,
the 1850s. That was 170 years ago.
well, like the Big
So,
Bang Theory, that's no older than like 30 years ago or something, isn't it? All those things
uh,
you mentioned.
um, no, the theory of evolution was in the 1800s, and
Was it?
yeah,
Does Darwin go back that far?
yeah, and so um, so so anyway, that's why there are things missing because they were not allowed into the regular scientific community. I work in electrodynamics, and the electric field was called by the people who were doing the work, like Maxwell and Ampere and those type of people. It was called the Spirit of God. Well, the people who didn't like religion, they didn't want to call the field the Spirit of God, so they did all kinds of things to make sure it was a totally different idea. And then when we developed quantum mechanics, you know, uh, we could have had everything in terms of the field, but we didn't. We used the universal wave function, and all material, all matter was a quantum fluctuation of the vacuum, and then you produce. And so you have all these different ideas competing for attention, and uh, uh, and that's why when Henri Poincaré saw that, and he died in 1912, but he had developed what's called meta theory, which are the theorems based on logic that apply to all theories in science. And he was trying to correct that so that we could get back to truth. And of course, Poincaré published the theory of relativity a year before Einstein did, and then he showed from his theorems that it was a false theory, it wasn't true. And but people didn't like that, and so they moved to have Einstein's theory adopted in places like Copenhagen and stuff like that, where you had the big scientific meetings. And so anyway, you've got a lot of things that are factors that are affecting the theories in science, and uh, they cause people. It's kind of like politics. If you've been watching the politics for the last couple of weeks, you see how different parties do things, and they may not be based on truth or whatever, but they get attention, and sometimes they get their way, and sometimes they don't. And so that kind of thing, that kind of politics is going on even in the scientific community.
So
And
that's interesting. You bring up, say, the history of the United States, but obviously other places in Europe and Russia and things like that are not bound by any such restrictions, or are they?
well, they had the same kind of revolution revivals occurring, particularly in Great Britain and Ireland and Scotland. But also, you had the same thing going on in Germany and some of these other countries in Europe. So yeah, and but today the politics is different in different countries. Like for instance. Uh, when I give some of my presentations in the United States, I get fired from my university position for having told that, so that people would know that logic disproves, say, the theory of special and general relativity. And but if I go to some country like Russia, well, they don't care about that. They'll even pay my way to come and speak. And so it's not the same in every country, but some countries have a stronger um, battle between religious groups and other groups in the country, and they try to fix it so that you lose your job and your source of income if you don't agree with them, and and that's the way the United States is right now. And
Well, I mean, you touch upon this thing about how you can get fired for believing in kind of different things.
yeah,
Now, luckily, they don't burn us at the stake anymore, but certainly they are free to fire or ignore us or
oh
call
yeah,
us, crackpots and all the rest.
yeah.
But at least they don't burn us at the stake.
No, but
But
I tell you, the people in our group who have published papers with me have lost their jobs, and it's sad. I lost
that's why
my
you got
job.
to be like me and not have a job in the scientific community. Just be a nice, safe computer programmer, and you
Uh,
can say whatever you want, but
That's
yet
what I
still be
did
complete.
too.
Just be
I'm in the computer field. That's how I did most of my working career, and they didn't care about these issues in the computer field because that wasn't their topic.
Yeah. You weren't threatening them there in that topic, not unless you were saying that your computers are too fast and you were threatening the government contracts,
Yeah,
which
yeah,
was even a bigger problem, right? So
yeah, yeah. That the swamp, as we call it, they didn't like people who would reduce the income that they could get from uh, being able to manage contracts and determine how much they wanted to spend on these things. And so, and the amount we spend in the government is still an issue. I think we spend too much to do many things, and we're not very efficient. And but the people who are in Congress and get elected, they cooperate with these things, and they get some benefit themselves. Um, I think I've mentioned before that my father used to work for Congress, and he said he never met a congressman who wasn't making about $1 million a year out of his position in addition to his income, his salary. And and every time they did a vote in the House of Representatives or in the Senate, there were give you a check for $10,000 or $5,000, and you do that day after day after day, you're going to make $1 million. And so there's just many things going on, and sometimes someone will say, "Well, I'm not sure that's a good thing," but we just cooperated with it when we got to Congress. We figured, well, if everybody's doing it, we'll just do it too, and that's what they do. And
So, but your main argument here is that science has kind of gotten into a rut partially because of the bias against religion.
the people
So,
who don't like the see when we had these revivals and that sort of thing going on in the country, the question of sin and stuff like that was coming up. And if I'm not a religious person, well, I don't pay attention to that. But I don't like everybody in the society talking about it, so I'm going to oppose that. And so that's what has happened. And and these people they find that they can have more authority if they represent science. So they try to, become associated with that, and and different theories have politics behind them. And just because you have invented something like uh, Tesla uh, and some of these other people who worked in science and came up with new electrodynamic things, they were opposed, and uh, it was hard to get everything accepted that you had worked on, and people would burn down your building where you're doing your work and all kinds of things uh, to try and stop you from doing things. By the way, uh, I'm working in with a company called Boeing, and we have developed an electrodynamic inertial propulsion system, and we're now using that on 3,000 satellites that are in the process of being put up, and they're low-level satellites, and they don't require that you have a satellite dish to receive the communication, and they're going to use this propulsion in cars, and the cars will have no wheels. The cars will not require a road, and they will not require any fuel. And they will use a nanotech crystal that uses the work of one of my sons for a new theory of the atom. He found that there were emission spectral lines and absorption lines in the extreme ultraviolet, which is 500 to 1,000 times the energy of the other spectral lines for hydrogen and other atoms. And but now people are being able to use this and to make a solar panel that is, 500 times as much energy per square inch as the ones that are being marketed right now. Well, a lot of people don't want that to come out, but you see, with that, you won't need power plants, you won't need uh, gasoline or fuel oil. Your car will run on that. And these cells, nanotech crystals, they work 24 hours a day. They don't just work in the daytime when you see the sunlight. And so uh, there's for the people who want to talk about a green planet, and they want to talk about global warming and that sort of thing. Well, they should be picking up on this, but interestingly enough, they're not. They won't even talk about it, and because the industries that they have set up for to work on global warming are not required, and they can't
okay.
compete, and so they don't want to admit, oh, we got the wrong theory of the atom. We if we had the proper theory, we could make uh, solar panels that are just 1 foot square, and one panel would be enough to to uh, make your car go, and it would be enough to power your house with everything in it. And you don't have to put it on the roof. You can leave it inside the house, so you don't have to worry about the weather and all that kind of stuff. And but you don't hear anything about it.
All right. So I have to go and take care of something. So, Bill, why don't I put you in charge I think we've got everybody on the stream on the screen here. So continue discussing, progress in science. Maybe Ian can start it off with what his opinions are.
Okay. Ian?
Just unmute myself.
Oh.
Okay. As usual, one is stimulated by the conversation, and one likes to listen for a little while before formulating further thoughts. But I think as you were talking, Bill, I was thinking that humankind has a propensity to wish to assemble in a herd and develop a herd mentality and develop an orthodoxy and persecute anyone who is outside that. And that's what we have now. I mean, I've said in the past that science is a bit of the new religion. Like hundreds of years ago, one had religion as the orthodoxy. Now one has modern science as the orthodoxy. And as Franklin said, well, perhaps they don't literally fire you with faggots, but they as you said, and you've experienced, Bill, they fire you in a less pyrotechnic way. So that's it. And there is unfortunately universality to this sort of herd instinct and persecution, and not wishing to have established views questioned. And one of the things you mentioned in Russia, and I had a similar experience, I suppose in 2004 when I was at the St. Petersburg conference there on space, time and gravitation. I felt actually relatively free to speak in comparison with the feeling I sort of had in the West at that time. And I put it down to a bit of maybe the collapse of a very rigid political system, the Soviet system, and they were all of a sudden they wanted to go to the other extreme and accept new views. So I'm not sure what it's like now after another 16 years or something. But I sort of found that at the time there was like a bit of a new freedom. But that can degenerate very quickly into another persecution. We actually do find that in history with sort of revolutions, against established systems, that the new systems soon become quite as authoritarian as the old ones. For example, the Soviet system was probably far more authoritarian than the Tsarist system ever was. So you get that sort of thing. But I do take the point that there is an orthodoxy, and it's very difficult to question it.
Let's see.
Did anyone get the email I sent out about with the cargo cult statistics?
Could you say that again?
That doesn't ring any bell with me, Dennis.
Sorry, I don't know the right email addresses to send to. I guess I sent one to Franklin and one to Bob Gray, but and I sent to some other, like the relativity group and so on. But anyway, this is cargo cult is during and after World War II, the natives in the islands in the Pacific would try to imitate the radio transmitters. They'd have boxes and so on. It looked sort of like a radio, and they'd have someone outside howling like static and so on. And they paint USA on their backs in bright colors, hoping to get cargo, supplies and whatnot. And it was Richard Feynman who first used the term cargo cult statistics. And it's basically using statistics not to find out the truth, but rather to convince people that your theory, whatever it is correct. it's a perversion of statistics. And I was hoping we could discuss that a little bit, but I guess no one looked into that if they got it. And it's an article by a professor of statistics at the University of California at Berkeley, my alma mater, who's also associate dean for physical and mathematical sciences. So if you look through your inbox, you may find it. It's only about a page and a half, but it's very informative.
Go ahead, Ian.
Franklin. I might follow. Ian.
Yeah, I beg your pardon. Just since Franklin came back, I was just going to give a little addendum because I was saying that mankind has a propensity to orthodoxy and to establishing in groups where any of the outgroups would be persecuted. And I was going to say, somewhat provocatively, that I would even say that if by some miracle in the morning our views, say with regard to modern physics, the sort of developments over the 20th century became accepted, I don't know how that might come about, but I mean, they might look at the experiments, or it might just become politically expedient to accept our view and say, oh, we've been completely misled by Einstein, and there are other ways of looking at it, and we were completely wrong, and so on. I would predict that within a few years there would be an orthodoxy which would be our dissident science, and anybody who believed in relativity or what is the established physics now would be persecuted, and they would lose their jobs and so on. So what I'm saying is that it's not just particular views that are persecuted. It's mankind's propensity to develop into an in-group, establish an orthodoxy, and just accept that. I mean, I'm just reading in the paper this morning something we all know. They were just indicating some articles maybe about 8 to 10 years ago in the press here, where all these sort of global warming people and so on, climate, they were advocating, and the government was advocating very strongly a move to diesel motor cars here. And it was the greatest thing. It would save the planet and so on. And, that was a position they were taking. And the tax rates had come down and so on. And it was arguable. Now they're saying the exact opposite, that these very things are polluters of the planet and they're causing cancer in people and so on. And, you daren't question the orthodoxy. The orthodoxy just flips like that. But once it's the orthodoxy, that's it. You say, oh, the experts say this, the scientists say this. Oh, yes, 10 years ago we were wrong. I know we said the experts said this and the scientists said that, but that was incorrect. We've now learned better. We've now looked at the further thing. And that is the definite truth.
Well, I think that may be true, but even in science, there's certain subjects like we always discuss, like, say gravity is. Now, there's this topic where there is actually no orthodoxy, I don't think, about, how the things like the basic forces work. So for something where it's basically still up in the air, then how is it we've not made any progress on, say, what gravity is? I think by the year 2020, it should have been cut and dried, and everyone should have been able to figure that out. But it seems that even in the mainstream, even in the orthodoxy, they have no clue. So I guess that was kind of the kind of what I was driving at. Is like, why is it in this late age that we don't really know what things like gravity or the magnetism or actually the origins of any of the forces actually are? We're still kind of shrugging our shoulders as to what that thing is, and we have maybe some crazy theories, but I don't think anyone in the orthodoxy would come down and say, this is exactly what we think these forces are. So what do you think that is?
Yeah, it's a very good example, gravity. Now, and it always has been. I mean, from the time of Newton, Newton worked out the results that obtain from gravitational interaction and so on. But ultimately, when asked, what is the cause of gravity, he says he cannot see other than that it needs a divine hand to impress it upon the earth. So and that's now called the God of the gaps. Well, if you can't explain something in science, just say it's supernatural or something. Now, I do agree that they haven't really progressed since then, nor do they claim to have. But I think they are probably liable to be quite harsh on theories like the Lesage theory or electrostatic theories that maybe you might have, Franklin, so on. I think if you put those to an Orthodox forum, I think you would be ridiculed. I don't think you'd be given a very fair hearing.
I think there's another area too that needs to be mentioned, and that is a lot of people who are very wealthy have their wealth determined by in certain industries. So, for instance, in my work on gravity, where I say that gravity is due to the average electromagnetic force between neutral electric multipoles, such as dipoles, quadrupoles, and octopoles, in atoms. And when you do that, you derive the force of gravity, and you're able to explain what Pioneer 10 and 11 measured in our solar system, which doesn't agree with general relativity or Newton's universal law of gravitation. And it also explains the velocity of the outer arms of spiral galaxies. And and then this theory has the oscillation of the dipoles, they radiate energy off and they slowly decay. And so that decay is causing the Earth to expand. And when the Earth expands, the atmosphere gets thinner and you have global warming. And that is the primary cause of global warming. But they don't want to admit that because the industry they're promoting wouldn't help solve the problem. And it just contributes to their wealth. And so you've got a lot of things like this going on, and they don't want the truth to be broadcast very widely because it would hurt their industry. It would hurt their wealth. So we've got all of these things going on simultaneously, and it's caused people, for instance, they want to sell you the traditional solar panels, they want to sell you the windmill things and stuff like that. But the new nanotech crystal, I mean, it blows those away.
Yeah, you got a question about who's producing these UV energy panels.
The ultraviolet energy, there is a group in Silicon Valley doing it. They demonstrated it, the panel and the capability for cars last January, and they invited the head of over 1,000 companies to come and observe what was going on. And Tesla was the one who demonstrated a car, and they had a car. I think it had a 1 foot square thing of this new nanotech crystal, which is small, and they got the car to go from 0 to 400 miles per hour in 6 seconds. And they showed that it's faster than airplanes and all that kind of stuff. And they
You sure that's right, Bill? I'd have to color myself skeptical there.
Wait a minute. They said if you want to use this in your industry, you must put up $1 billion. And within 2 weeks of that demonstration, 1,250 companies put up $1 billion to use that. Now, that's true. That's $1.25 trillion that was put up to be able to use these crystals in their industry. Who were those companies? Apple did it they want to use it in their cell phones. all the car manufacturers wanted to use it. Um, Even Amazon wanted to use it,
I don't know, Bill.
and
We're asking
Uber
for
and all
names.
these places. They put up to $1 billion each, and they passed
So was the
laws.
company Tesla?
Pardon?
So was the company Tesla?
The company wasn't Tesla. Tesla just made the first car that used this technology,
Yeah, we want to
and
know what the name of the company is who's providing these crystal technology.
it's not revealed except to the heads of these companies that have put up the $1 billion. It's not on the stock market yet, so
Well, isn't
it's
that
coming.
convenient?
Yes, and but anyway, one of the companies that put up the money was Tesla. They put up the $1 billion, but so did General Motors, so did all your European car manufacturers, and etc. And in the European Union, they've already passed two laws. One says no more gasoline or fuel oil powered cars can be sold in the European Union after the year 2030, and no more gasoline or fuel oil can be sold in the European Union after the year 2040. So they've only given the companies, 10 to 20 years to make this transition. And of course, they would probably do it faster than that, but they didn't want to hurt anyone because they didn't have enough time. And the country that is providing the source material to make the nanotech crystals is Saudi Arabia. They're not going to be providing oil, they're going to be providing the sand from which these are made. And they have a unique sand in their country that's useful. We have a little bit in our country, but not very much. And so,
May I add a little bit of perspective here?
sure.
Um, if you're talking about a group or a company that just raised 1.2 trillion in, I guess it's cash.
Yeah. They were.
The largest companies on the U.S. stock market, there's only one or two. I think it's Apple and maybe Amazon or whatever. And it's been big news in the last few months that their total market capitalization exceeded $1 trillion. So you're saying that here we have a company that, which is private, and no one knows the name of it,
Well, the
that has
people
0.2 trillion in cash. And you're saying that 1,000 other companies came to witness a demonstration by this so-called company or group, a private group. And you want us to believe that there was absolutely no media publicity about this.
There was media publicity, but it didn't include the name.
Putting this in context, well, that no one leaked anything about that. Of 1,000 companies that supposedly were invited to this demonstration, not one leak appeared in the press about such a thing, and that how a company has raised a record amount of capital in the history of the world, raising 1.2 trillion in cash without even an IPO. Okay, that's an initial public offering. In case for those who don't know, I mean the credibility here is it's almost sounding like a scam.
Well, it's going to go onto the stock market, but it's not there yet. In other words, it's not yet on the stock market, but it's coming. And
why would it need to go on the stock market if it has 1.2 trillion in cash?
Because
you see, again, that makes no sense whatsoever.
They're going to be selling products themselves, besides the companies that they're licensing to sell their stuff, and they don't have very much of these crystals available at the moment. They just enough to do a sample, like Apple made a phone that ran on it. Didn't have any batteries in the phone, would work anywhere on the surface of the earth, and would work 1,000 times faster than the current ones that are G4. So with the
Oh,
G5,
okay. Well, all I'm saying here, my only contribution here, is that this is completely, the figures that you've given are completely, to put that in context, it would be a world record financial event never seen on Earth before, and
right.
yet there's not a peep about it in the media.
Well,
This is very
that's not quite
uh,
right. That's not quite right because I get a lot of stock investment newsletters for the stock market, and
okay.
they're all telling you how to benefit from this. In other words, what can you buy? We can't buy this stock because it's not available, but what can you invest your money in that is going to be using it and it's going to make a lot of money? So they're telling you how to do that. So that's what the newsletters are. But they didn't give any name of a company that would be on the stock market yet.
Or
So,
even name of a person. If there's a patent, is there a patent application?
um,
If
I
there's a
suspect
patent,
there is.
there
I
would have
suspect
to be
there is.
names associated with it.
Yeah, I suspect there is a patent, but the stock market newsletters that I get did not reference that. So, and
Well, I think
I,
this is kind of like uh, that. There is a certain amount of truth about, say, the piezoelectric technology, because definitely that is a thing. But sometimes these technological aspects are maybe blown out of proportion. Now, me personally, when I looked into the newsletters, because I know about the newsletters that Bill is talking about, and I looked at the piezoelectric reference.
anybody there?
Hello.
Hello, just went dead there for a moment.
Yeah.
Hi, Ian.
Hello, James.
Well,
I think
if I can be heard while Franklin is getting back online, I might develop a thought that you developed last week, Ian, about what I would call the branding of these groups, where Dennis, let's see, the guy who hosted Hilsinger last week was saying that
Dave,
he's trying to get different groups involved, and whether or not these groups should include really far out groups like flat earthers and things like that, and where you draw the line. I think, Ian, you gave at least me the key to the answer to this question, that we should be branding ourselves as physics research using the scientific method. This then, that's my, 4 or 5 word summary of what you were saying, what we are, because you were saying we're not really out there in terms of rejecting the scientific method, that we're using the scientific method. And so I think that's how this Saturday chat and others should brand themselves now. In other words, I'm making a branding point, and that in these chats and in any meetings that David Hilster is planning, this should be the main thing, that we are a group of people interested in physics research using the scientific method. Those groups that are not using the scientific method, they're obviously not in our brand. End of story. Thank you.
Well, there's a lot of different scientific methods out there, and we're using. Starting about 1850, we switched to the existential scientific method, which took the role of logic out of science. So, for instance,
Okay, well, I agree with you, Bill. So maybe we need to add one more word to our branding, the traditional scientific method, if you will. For those people who teach, I've taught courses in the scientific method at the college and university level, and there are textbooks on this. So yeah, which in other words, where things have to be logically consistent.
Yeah.
Okay, where the flat earther people are not logically consistent, for example.
See, I think one of the things we were mentioning last week was, or maybe I put it forward, is that the term dissident by itself was a bit negative.
Yes.
It said we were rebels or something, but it didn't really say what we were for. We could have
Right.
been against using logic, against using some form of scientific method, and we were suggesting, well, what you've just incorporated now, that perhaps we should have a sort of a positive brand where we say we're using X scientific method, or we're establishing a correct logical procedure or something like that, rather than just bare dissident in itself, which could mean
So with this branding, with this kind of branding that Ian gave me the kernel of the insight to raise this point, it means that physics students groups around the world, physics faculty and physics in college and university physics programs are all fair game to recruit into our chats and into our meetings. And in fact, most research in physics now are challenging one view or the other, and they're attempting to gather data to support one view or theory or another group, another theory, so that in other words, people opposing the status quo are common in the physics community today, but we're neglecting this group. And this is probably the largest, most competent group that we could recruit into the chapel, naturalphilosophy.org movement, if you will. Thank you.
Well, a lot of the physicists who are challenging the current view are ones who are heavily influenced by high-powered mathematics. They don't use mathematics as a tool in physics. They use it as a guide. But this is wrong because mathematics contains so many possibilities that you can't ever get through them all in a lifetime even. So you first have to find out what you think physically, and then use mathematics as a tool to work with it. And I have here a book by Professor Alexander Dmitriev of St. Petersburg, Russia, which is mostly in English, partly in Russian. It's called Physical Gravity. And he talks about gravity changing with heating. The weight of an object changes when you heat it, way more than E equals mc squared would predict. And it also talks about weight change with rotation and vibration. And he has this whole book, all these papers. He's a very meticulous researcher, and he's getting nowhere because it's the mathematics in general relativity involves Riemannian geometry, which is one of the most beautiful parts of mathematics. And the people are going for mathematics nowadays, not for physics, even though they may be physicists.
Let's see here. We have Alistair. Alistair had some comments in the private chat here. Did you want to say something? There you go.
Sure. I think there's limited value to the current scientific method that I don't consider unquestionable. For example, if I said something like, oh, I predict that unicorns are what makes up the universe, and I predict that the sun will come up and roosters will crow, and then the sun comes up and rooster crows. Does that make unicorns the composition of the universe? No, because confirmation of a ludicrous theory by its ability to predict a phenomenon is not adequate justification for accepting its cause. So I don't agree with the scientific method being unquestionable.
I think, Alistair, what you've just defined is observations that lead to superstitions, that one thing happens and then another thing happens, and people ascribe a cause and effect to it. What is missing in that is statistics. You have to show that the the explanation that you're giving or your hypothesis is the uh, uh, um, most parsimonious account of the phenomena. So basically, what you've described is superstition, and by definition, a traditional concept of physics research according to using scientific method would exclude that. In that context, it would be called superstition.
And also, Alistair, you've said two things in the chat and in your finishing remarks there. You just said you have skepticism about the scientific method, but in your introductory remark, you said, I think correctly, that you have great skepticism with regard to the accepted, the scientific method, the way it's actually being implemented. So I think we could question how current science is actually implementing a scientific method, despite all their claims. But that's quite different from saying that we don't accept the scientific method. That could lead to superstition. You could say, well, we just accept things that we feel are right or something like that.
I did not say that there shouldn't be a scientific method. I said that I don't think that it's unquestionable. It could be improved upon.
Well, I think that's where the role of logic comes in, and for instance, when I spoke against the theory of special and general relativity, I showed by logic that the assumptions of special and general relativity theory are known to be false, and there were 5 of those assumptions that were known to be false. But the theory was making predictions that agreed with at least some data, and so the scientific community did not want to recognize the scientific method that used logic as part of the method, and they wanted to be able to have these theories accepted, despite the fact that they're illogical. And so I think that is the problem. And when you look at the scientific method that was in use at the time of Isaac Newton, it had both logic and experiment. So you performed experiments and then you used logic to make conclusions. And the thing that I did in electrodynamics is there were 8 empirical equations and 8 unknowns in electrodynamics, and logic says, oh, well, if those are valid empirical laws that you have discovered by experiment, and you solve them all simultaneously, you'll get the best solution for electrodynamics. But we didn't do that. We discarded 4 of the 8 equations and just used 4 called Maxwell's equations, and we did that, and we got an incomplete theory of electrodynamics, and we had to supplement that with quantum mechanics, special relativity, etc. In order to be able to explain things in electrodynamics that we couldn't get from our solution to Maxwell's equations, that Oliver Heaviside had reduced from 8 to 4 equations. And so logic says, well, if you've got 8 equations to solve for 8 unknowns, you solve them simultaneously. But we didn't do that. And then they were incomplete, and so we invented supplementary theories. And for instance, Einstein's general theory of relativity cannot explain gravity in our solar system. What did we do? We invented a second theory to supplement it called dark matter and dark energy. And that dark matter and dark energy had to comprise something like 96% of the universe. And we've never experienced it directly. You would think we would. And But then if you had solved the 8 equations of electrodynamics simultaneously and then derived the force of gravity from that, you wouldn't need dark matter and dark energy. And so what we find is our scientific method, we have removed the role of logic. But we didn't stop with the existential scientific method. We went into the further method called the postmodern philosophy of science and its scientific method. And in that scientific method, we said, oh, the scientific theories and experiments we do are only good within the silo of one field. So if a chemist discovers the source of gravity is electromagnetic, well, they can talk about that in chemistry, but not in physics, because we don't accept that in physics. And so each field, biology, chemistry, astronomy, etc., they all have their own silo, and what they do is independent of the experiments and the logic of developed in other fields. And that's why we no longer have the university. We have a multiversity. Each field is a separate department, and they get separate grants, and they're independent of one another. And that's not the way to discover truth, I don't believe.
So we got a comment from Roger here. He's saying that, the flat earthers probably think that they are logically consistent, and I think that would be can be applied to just about anyone. That logically they're consistent, but they logically are able to do this by saying that lots of the empirical evidence is hoaxed. So everything that NASA says is lies. So in that way, even those people can claim that they're using logic, right? So the logic is that what you say, what has been said by the mainstream is incorrect. So there's a certain logic to that. It's like there's some recent discussions about, say, the theory that space is filled with positrons and electrons. And so the argument that was going on was that, well, obviously we know mainstream says that positrons and electrons annihilate and they couldn't possibly exist, so therefore your space can't possibly exist. Is the argument being made there, right? So what you have here is a situation where you're claiming, you would have to claim that what the mainstream is saying is incorrect, and that may in fact be the case. But there's also this problem with the mainstreamers using basically a circular argument, in that you are trying to disprove the other point by using the very thing that's under contention, which is whether annihilation exists, right? So, I mean, that's a little bit less obvious than flat earthers saying that, everything that NASA says is wrong, versus saying that when an electron and positron come together, they don't just completely disappear in energy. The claim is that they come together and they form a new neutral particle, which is the ether particle of space. And but both of those are consistent with the observed facts. But I'm just giving that as an example of what Roger's saying is that you can reject the interpretations of mainstream and still remain logically consistent. But I'm thinking other people are bringing up the point that the way you tell the difference between those two theories is that you need to do some kind of experiment that would help you determine what is the truth. So for this example, when you have a positron and electron and they come together, you see gamma rays come out. So one hypothesis says that they are completely destroyed and there's nothing left. And the other hypothesis says it formed a new neutral particle. So if someone wants to say that this formed a new neutral particle, then that hypothesis would suggest the experiment that neutral particle should be detectable, right? It's still there. It should still have kinetic energy. and there should be some evidence of it coming out. So that's, I think, an example of the scientific method where you have the hypothesis makes a prediction, but it needs to make a prediction, I think, particularly of something which has yet to be actually observed. I think it is more effective than making a prediction of something that has been already observed, right? So if you could come up with a prediction, say, that you should see some situations where you see the positron and electron come together, they travel some distance, and then some distance away, they separate back out into the positron and electron, which is the common way, actually, mainstream scientists use to identify neutral particles. That's typically how they do it, because neutral particles completely disappear track-wise in their detectors, but they will see something typically branch out with the same kinetic energy of something coming in. So that would be a prediction. And actually, I think since I particularly favor that theory, that if you looked at the data, you would probably find lots of instances of that. You would probably see lots of instances where positron electrons seemingly come together, travel some invisible distance, and then separate, showing that the particle did not in fact annihilate. So that I would suggest that that's a way to move forward, right? Is to have predictions, predict things that haven't been predicted, and then actually have those predictions confirmed. Or do you explain things that can't be explained by conventional theory? There's another way that is typically handled.
See, I think the difficulty is that on all sides, they claim to be using logic and a scientific method. I mean, they wouldn't say, "Oh, I don't believe in logic. I'm just putting out things that I feel are right," and so on. They all claim to be using logic, all these contrary views. And I've wondered about this before, that people like me and us, we've looked into physical science and using the tools of mathematics, and we've found something that's surprising, actually, because so we say that the work that's been put in over a century or something like that by the best minds addressing themselves to this subject, and with plenty of money behind them, government money and private money and institutions, they've come to quite erroneous conclusions. Now, okay, one might say, well, that's the fate of humanity, But is it only in physical science that that's true? I mean, perhaps we haven't studied. Bill talked about silos, maybe chemistry or biology, or maybe psychology, or maybe less exact sciences. Maybe all the different studies. And are they really as sick as we say physics is? I mean, it appears to me that we're saying physics is totally sick. It's quite off the rails, maybe more so than other subjects. We say, well, history is biased. It's written by the victors, and there are political agendas. But that's not quite the same. It's not totally illogical. It's just maybe biased. Chemistry, we say, well, they're assembling, maps of the elements and compounds and so on, and what happens in reactions, and they're generally quite true. I mean, Rutherford, who got the Nobel Prize for Physics and Chemistry, he said that anything but physics was just stamp collecting, putting things together and just quantifying results. But is physics really so bad that it's a prime example, or it's the sole example of our having gone astray, or is this just something to which flesh is air, and that mankind has done this in all other areas? And if we studied other subjects, we would find similarly a lack of logic.
Okay, once again, I have to go attend to something here.
We do it in other areas. I would hold up as a primary example, well, of course, religion, but the other one being climate change, where we grasp onto this tiny concept, and with just the very minimalist of confirmation, consider it to be truer and truer, and form giant consensuses that should not and cannot be questioned without invoking considerable wrath and disdain. So yeah, I would say yes, it's something that we tend as a species to do overall. We grasp onto a term or a concept that we haven't heard before. It seems novel and new and unique, and it's associated with some mathematics, which seems to predict the repeatability of a phenomenon. So we go, oh, wow, yeah, that's right. And then everybody jumps on the, yeah, that's right, bandwagon. And then we got to where we are, believing in extra dimensions and time dilation and contraction and all sorts of such. Big bangs. And that's how I see
Yes,
it.
I think that is so. And I mean, when I was younger, I used to have maybe a higher respect for pure science as against maybe the application of it or technology. I said, well, you know, they're really looking at the fundamentals and they're going into very deep questions. And the other is just really manual dexterity. But as I've got older, I've been increasingly amazed at how technology works. I mean, despite what we claim are false physical theories, the technologists actually get these things to work. Maybe GPS would be one example. It just has to work. You put in the code and you make sure that it isn't wrecked up by special relativity. You put in things like Sagnac corrections, which aren't accepted by main science. And I mean, I think Harry Ricker pointed out a long time ago that before there was any decent physics, the pyramids of Egypt were put up, you know, with correct slopes that met in a point and so on. So the technologists get things right because they have to. There's a practicality, and they might be actually forced to get things right by the exigencies of life. You know, I suppose by their payment or by their status in society. But they seem to be completely converse when it comes to establishing theories. And these are prone to what you say, Alistair, you know, just getting some small pieces of data maybe and formulating a big theory which becomes orthodoxy, and it becomes maybe a hysteria, even like climate change or something, and you daren't question it, and, you know, it's established logic. So, you know, I'm amazed how the technologists are not actually generally led astray by incorrect physical underlying theories.
They can't get led too far astray, because when they do get led too far astray, their time machine doesn't work, or their transporter machine, or their warp drive, because when the rubber hits the road, they find that their knowledge of physics wasn't adequate. I know people that put some considerable money into some water tower that was supposed to manage to generate electricity by using some principle that would allow it to get water to magically flow up this tower and then trap the energy as it fell down the tower. I think it had something to do with, you know, that where you've got that globe with the spout on the top, and water will coil its way up the spout and start pouring out, but it doesn't last forever. It's using up an underlying component of the situation, and once that's used up, it's done. It stops flowing. You know, so these guys were wrong because they didn't understand the physics well enough. Or I know another guy who thought that he could get energy out of magnets, like a perpetual energy generation machine. And who knows, maybe he's right or wrong, but when they tried to implement the design they had, they ran into problems caused by induction, which they hadn't anticipated. And so their physics was, so you say technologists don't get led astray by poor theory. Well, they do. It's just that they don't succeed, so you don't hear about them. They're not the ones that you hear about because there's not 7 billion levitation machines. because levitating doesn't work, but there are 7 billion phones because phones do work. So it's not that the technologists don't ever go astray. It's just that they don't succeed at going astray, is my opinion.
One could say, with regard to our own field, say where we have electromagnetic theories of the 19th century and so on, and Marconi, say, and the early experimenters were probably incorrect in discounting those and saying, well, the theory said you needed a line of sight to be able to transmit electromagnetic waves, say from Europe to North America.
Right.
He just didn't want to believe that. He was probably illogical. He said, no, I don't accept what they're saying. I'm just going to go ahead. And it turned out he was lucky because there was an ionosphere which bounced back the rays. But, you know, I don't know. It's possible that had he failed, the technologists would have developed some other means of doing it. You know, maybe by putting reflectors up there or something like that.
Yeah, repeater towers or floating balloons or something.
Yes.
They've thought of doing that with the internet, the floating balloons.
Have they? Right. What's the problem with the existing system?
The floating balloons was to provide wireless coverage to areas that don't have wires coming to them of significant carrying capacity. So it was kind of like satellite, but because they were balloons, they're low Earth, and you can put up more of them because they're very cheap to launch. They basically self-launch as inflated compared to needing to get propelled up. So it was about just providing a significantly greater wireless internet, so rural areas could get it and such. So there are some projects in play by like Google and that have tested it, and they've had a couple of hundred balloons flying across Australia or something like that. I don't know. Anyway, I was just pointing out that yeah, the technologists are limited by the fact that they have to produce.
Yeah, and it seems a great incentive. It's almost like a survival. I mean, some of the entrepreneurs who push these ideas, maybe with advanced systems, and the ordinary people marketing it, and the workmen. I mean, if you speak to any of these, I'm generalizing now, they don't have a very high intellectual capacity, but they're able to get things done. They deliver. And, you know, I'd be rather skeptical about putting a project like putting optical fiber transmission or something in a county to a theoretician, to a scientist. He probably wouldn't be able to deliver. He'd be completely impractical.
Yeah, no, I do understand what you're saying and agree with it to a degree. Like, you know, there are 24 explanations for quantum gravity. If you do Wikipedia quantum gravity candidate theories, you'll find 24. But we managed to get a guy onto the moon. You know, so even though we don't have a clue what gravity is or even if it exists other than as a phenomenon, yet we managed to succeed. So the technology guys don't have to necessarily know the fine details in order to succeed. And
yes, this is the point I'm getting at. I'm wondering if concentration too much on the fine details is actually counterproductive. I mean, some of these people, as you say, don't get involved in the details, and they're able to deliver the project. And perhaps I don't know if it's just an innate property of thinking too deeply about an event, or maybe it's because of the basic illogic of modern science that we've mentioned earlier. But it does seem to be antagonistic to getting results, to developing. Contrary to what they say, and I think this is why they're actually preaching this all the time. They keep on saying, the mainstream, oh, nothing would work if it weren't for our science. You know, if it weren't for relativity and quantum theory and general relativity, you wouldn't be able to navigate yourself in a sat nav, and you'd be lost, and your electricity wouldn't work in your house, and your mobile phones wouldn't work, and all that. You know, so the lady doth protest too much, methinks. They say that so much that I'm rather skeptical about whether they inwardly don't know that they're trying to hide something. That it's not because of those things that the things are working.
I think if a theory leads to a belief that is contrary to intuition, excuse me, then once a person chooses to accept the theory and believe the conclusion, because they know it's counterintuitive, it's embarrassing to accept it, but they do because they claim they have to. And then once they do, because it's an embarrassing position to hold, they defend it even more vigorously, such as the Big Bang as an example. People recognize it intuitively that it's ridiculous, but they say, but that's where the evidence leads, so I have to believe that. And because they feel it's that way, that they're forced to believe it as opposed to choosing to conclude it, they will defend it vigorously, those that do choose to believe in it, because they're embarrassed by it. I believe, to a degree. They might not realize that's what's going on, but I believe that's what happens.
Yes, just to add one sort of slightly alarmist aspect to the conversation, like we were talking about suppressing independent analysis of phenomena, because this could very well lead to contrary views. But I mean, and we were talking about maybe persecution and so on, and losing jobs and all that sort of thing. But I mean, it could, bit of a stretch of the imagination, it could come to worse. I actually saw it mooted in some political dialogue of maybe some extreme people, green type people, that were suggesting that there should be laws introduced to make it a criminal offense to sow up some doubts about maybe the enormity of the problem of global warming or something like that, or climate change, you know. So, I mean, you know, we haven't quite got to the stage that our views are being made illegal. But I mean, if you got a sufficiently authoritarian system in, it would say, well, we can't have these people questioning relativity, because it'll wreck our GPS system up for the country, and we'll wreck the economy. It wouldn't be very, very hard for a demagogue to whip what is already sort of like an established orthodoxy and a dislike for anybody who questions that orthodoxy, to whip that up into a fanaticism, a persecution fanaticism. And maybe we've seen some things like that in the past in history, and it could happen again. So I just put that forward as a bit of an alarmist addendum.
If you're in the wrong forum, the wrong group of people, and you mention any doubt of climate change, you can get some extremely emotional responses. And there are definitely people out there who think that anyone who doesn't believe in climate change should be jailed or disallowed to speak, not get censored in public, and all sorts of things. There are definitely some fanatics out there.
And by the way, just to give a scientific aspect to it, I don't know if you're familiar with this on the other side of the Atlantic, but some years ago, the University of East Anglia in England was exposed for having falsified the results of a climate change analysis to enhance the effect that they wish to produce.
Yeah.
You know, it was deliberate falsification of scientific data, and this came out. It was a big scandal. But at the time, there were arguments that it's all right to do that because this is such a serious phenomenon that the world is subject to in the coming years, that anything that would make the populace think more seriously about it, even falsification of data would be permissible. I don't know if you're aware of that, but that happened, I don't know, about a decade.
That's not too surprising. That's not too surprising because ultimately it's the problem with physics is an ethical problem and hence a religious problem. I read the other day that in communist China, the People's Republic of China, they asked the military to analyze. It turns out that IQ people will tell you that the group of people with the highest IQ are Orientals, then Caucasians, and then the remaining people in that order. So the question came up, and the communist China wanted to know why aren't they ahead? Because there's so many of them, and this what I just mentioned. And the answer came back: Christianity is a problem, is the reason, because it's dishonesty that causes ethical problems in physics and the sciences, and you're not to, according to Christian morality, you're not to go around lying to people. Whereas in other countries, that it's considered a matter of fact. Of course, you lie to people because you want to get what you want. And so the Chinese Communist government was reported to by their military leaders that the reason that the Orientals aren't the greatest scientists in the past few hundred years, even though they're more intelligent, have on the average a higher IQ, was because of Christianity. That's what they told them. And of course, these people are not Christian sympathizers. I mean, every day they burn down or blow up a church, it seems, out there. So I thought, that it's an ethical problem and hence a religious problem.
While we're considering the geopolitical aspects of what's going on in science, I might throw out something perhaps even more controversial. I've written and in videos recently talked about these huge so-called international collaborations where over 1,000 quote-unquote scientists are involved in the Atlas project, the Alice project, both of those at CERN, and the LIGO project, involving many dozens, 30 or 40 different countries. And my view has been, I'll try to be very brief, that the probably each of these projects require only 2 or 3 physicists, and certainly not more than a dozen. And you don't need thousands of them in many different countries in order to do these projects. So what is going on here? I think these thousands of physicists in these many dozens of different countries are all receiving stipends. And a sort of conspiracy theory might be that these physicists in all of these different countries are being bought off to participate in these projects and therefore muted, and therefore any kind of independent thought or research that they might do would be aborted. So it's a following the money scheme. So if you're worried, let's say the United States as one particular country is interested in maintaining a scientific and technological lead in the world for military and economic reasons. Well, what do you? All of these physicists, in these many dozens of different small countries around the world, are a threat. They could come up with advances in physics, fundamental advances, which could be very, very threatening. So what do? You buy them all off and get them to participate in projects basically as technicians. And so there's a conspiracy theory for you that these projects.
That's right.
Yeah.
I don't buy into that. I think that is ascribed to, well, and I'll say why. I think it ascribes them too much intelligence. That they all know that they're participating in something that is. Sorry, I got to turn down my volume. Of little value. Like say the 21 billion for the New Hadron Collider. How many of the people involved do you think would stand up and say, yes, this will definitely produce results worth $21 billion? Or how many of them do you think actually don't know and are skeptical and doubt, but they support it anyways because it's the perpetuation of their group of livelihoods, their mass, their industry, the thousands of people that work for the current Large Hadron Collider. Of course, they're going to be in favor of a new Hadron Collider that costs $21 billion.
Yeah, the scientists nowadays are careerists. Scientists nowadays are careerists, and they're out to advance their career, and truth comes as completely second place. They're out to advance. They want the big three: prestige, power, and money. That's just some of the whole thing.
So I don't think that they've been bought per se, and that they know they've been bought. I think they've justified they justified the costs of their existence, and they get funding for that. But you see what I mean? Where the difference is, that's not. Like the overseers aren't oppressing people because they're worried about what the people may figure out. The overseers don't have that much intelligence to know that there's something better to figure out. So,
well, yeah, in a way, it sounds like Alistair sort of maybe agreed and in part or disagreed in part with the theory that I was proposing, that these large international collaborations, quote unquote, that's what they're called, involving thousands of scientists in up to 3 dozen different countries each. Now, most of these scientists are going to be in countries with lower economic standards and ability to do research. And so a little bit of funding that may come in, and the prestige factor, as Alistair said, of promote and as Dennis said, of promoting their own career, where they could say, look, I'm in this little podunk country, but look, I'm part of an international project at CERN or wherever. But what I'm saying is that the net result is that all of these highly talented, very intelligent people are then diverted from independent thought. And what advances in physics might they come up with if they simply pursued that rather than being sort of, if you will, paid off by being recruited into these international scientific collaborations? So I think that it could be that some people up there at the top have decided one way to maintain our lead in technology and physics fundamental advances would be to prevent bright minds in other countries from pursuing independent lines of research, where they might uncover stuff that is going to put us at a great disadvantage. And therefore, we're going to hatch this idea of having international collaborations. I mean, what in the world in colliding particle physics, high energy, so-called high energy physics, do you need 1,000 different people to figure out what your research design is going to be, and your experiment and your observational methods and so forth? You don't need 1,000 different physicists to figure that out. Come on, give us a break. So that's my conspiracy theory.
So you talking about CERN?
I might add, if I may, we've all had experience of working in life and so on, and I'm sure that there is a de facto hierarchy in science. I mean, obviously there should be no hierarchy. All our views should be equally acceptable. But I mean, take CERN. I don't know, just take that as an example. I'm sure every Monday morning they have a meeting. It's sort of a board type meeting, or a meeting, a divisional meeting, and the director of it or something, or the person who's in the high position, has a bigger say. He says, well, look, we do this for PR reasons, and we put this out, and I want you to put those results there. Oh, what, you're a young scientist, you found these results with these particles. No, we'll keep that aside, put that down. That must be wrong. Have a look at that again. And, people are worried about their careers, and they're all lapping up to this big guy, or it could be a big lady nowadays. And there's a hierarchy there. It isn't a view. And furthermore, at these sort of forums, there's what I referred to earlier. There's this sort of herd instinct where there's a general consensus around the table, and to express a contrary view, everybody will be looking at you, and all of a sudden you're an out person. Now we've probably all experienced this to some extent in different avenues of life, and I've experienced it to a certain extent in science, although I haven't been involved in academic science for most of my career, but I have experienced it. I'm sure it takes place. And if you put it to these people, they would say that's the antithesis of what we're doing. We don't do that. But I'm pretty well sure that they are doing it.
Well, you see, like think of someone like Newton, who came up with this hugely important mechanics that's quoted and used even today, in rocketry and everything else. What huge budget did he have? Did he need 1,000 collaborators to figure that out? So that what I'm saying is that even in poorer countries, without a lot of financial resources, bright minds who've studied physics, they've got their physics PhD, maybe in a foreign university or whatever, and going back home. Any one of these very talented, intelligent people might be coming up with some real breakthroughs if they weren't included in these international collaborations and diverted from independent thought. That's my theory. In other words,
that's right.
Go ahead, sir.
The whole thing is to build the career of they and as many other people as they can get on board, because money and power and prestige are the ways to go as far as they're concerned. They don't really care if their results are that wrong. For example, Professor Weber, remember him, the big cylinder of aluminum detector of gravitational waves. Everyone thought he'd finally detected gravitational waves, but then they found that it was not true. But it didn't really matter, because since they're careerists, his detector now is in the Smithsonian Institute as a part of the great adventure of science, when the whole thing was a hoax. And things haven't gotten better since then; they've gotten worse.
But as regards to the point that James made with Newton, I mean, it is true that in the past, the fundamental research, which was undertaken in various aspects of physical theory, was undertaken by individuals. I mean, Lord Rayleigh, for example, in the whole theory of sound, he had his own laboratory. And you had a lot of sort of like aristocratic type people who had some private means. But you didn't have these big conglomerates, and I don't know, 99.9% of science, for the reasons you probably give, is undertaken now in these big conglomerates, and other people are maybe just pushed aside, or they're brought in to silence them, as you suggest. And they say, oh, it would be impossible to do meaningful physics now without large sums of money, and even one country couldn't do it. We have to cooperate. But I don't know if they're getting any better results. I think they're just being more politically savvy, probably to advance the interest that Dennis mentioned there.
Yeah, that's right. That's exactly right.
Well, Ed asked, what has particle physics given us that we can actually use? It's like, yeah, we've got CERN going on. We spent the billions of dollars on that. So what can we actually use from that? I'm not sure.
There are a number of things that we can do with particle physics. We've been able to make medical uses of beams of different elementary particles. I was involved in using pion beams, negative pion beams, to treat inoperable brain tumors. And I got a grant from National Science Foundation to treat 1,000 patients with inoperable brain tumors. And we made a beam at Los Alamos of negative pions, slowed it down so that it would just go through the skin and the skull into the brain where the tumor was and stop. And when it stopped there, the negative pion replaced a negative electron, and the negative pion went inside the nucleus because it's so much heavier than the electron, and it caused the nucleus to break apart, to become slightly different than it was initially, and that caused the molecule that was there to change, and it caused the cells in the inoperable brain tumor to die. And so there were some x-rays and stuff like that coming out of the process, so you could form a picture and see where the beam was going. You could see the outline of the tumor, and you could move the beam around and destroy 80 or 90% of the tumor. And then the body would clean up the mess and that was left over from all these dead cells, and then the tumor just went away. In fact, out of 1,000 patients, 990 had their inoperable brain tumors completely destroyed and no other particular side effects. And so that was considered very successful for in the medical field. So you have that kind of thing going on, but that doesn't mean that your theory of elementary particles and all the results of all the experiments you're doing are correct. It only means that particular one is valid. And your explanation as to what happens when a negative pion slows down and gets close to an atom, uh, what happens? Does it kick out an electron because it's heavier and got the same charge, and all that kind of stuff? You have to see if that fits with what you observe, and it does seem to fit. We see the when you have an ionized atom and you introduce an electron back to it and it cascades down to the lowest energy state, you get all these different emission spectral lines out, and we get the same thing for a negative pion. And so you think we got it in that case. But so anyway, we do make some progress in certain areas, but the medical profession didn't want to use this. 99% success rate. Well, that's pretty high. Uh, they wanted to do more things like chemotherapy, immunotherapy, radiation therapy with a different kind of radiation, and they're using electrons and positrons and muons now, but they're not using pions. And so anyway, we see that even though the money is paid and the experiments are successful, they don't necessarily use the results because there were some political reasons in the scientific community, and that caused them not to want to do it. And so that's my experience when I was at Catholic University, and I had been hired to the highest paying postdoc position in the United States of America to do this work. And while I was there doing that, I happened to give a paper before the American Physical Society on how logic falsified the theory of special and general relativity. And for doing that, I was fired from Catholic University by the National Science Foundation and Department of Energy. So
Now, speaking of relativity, one of the topics that has been coming up is time dilation, which is that say atomic clocks seem to run at different rates depending on, say, how far above the Earth they are, or what their relative motion is. So I was wondering, Bill, did you have any specific comments about why that would be? Why are clocks affected by either gravitational potential or by their absolute velocity? Certainly that's a relativity thing.
well, in the work I do, it's all in electrodynamics, and so all the forces in nature I have been able to derive them as being entirely electrodynamic, 100%, and that's to 8 significant figures. So I think that it's resolved, but the scientific community doesn't agree with that. And but when you do these experiments electrodynamically, you can predict these kinds of effects, but people don't want to recognize that because it doesn't agree with their own theories. So I haven't published papers particularly on that issue, but other people have. And so you can see from the response to these types of papers what is going on in the scientific community. And but for instance, my son's theory of the atom, which has more spectral lines than the Schrodinger and the Dirac model of the atom, or theory of the atom. And these enabled us to make a technology, a crystal, nanotech crystal, that could absorb much more energy coming out from hydrogen and helium gas throughout the universe and being delivered to the Earth. And so the technology and the usefulness of it may cause the current theories of the atom to be falsified and rejected, but so far it hasn't happened. And even though there's a technology that's based on this work, and we have to live a long time to see the effect. I mean, like Galileo had trouble in his lifetime with the work he was doing, where the Earth was not the center of the universe, but it was the sun, and he didn't see that very much success during his lifetime, and I think that sort of thing happens today too.
I might add that Andre Michaux, a French-Canadian physicist, who's written a book on basic particle electrodynamics, or some such title, has emailed me, and he says that he can show that cesium clocks do slow down and speed up according to those two things, absolute velocity and linear velocity, and also how far you are into a gravitational field, the gravitational potential. He can show that by his theory, which is in, he's got a book put out by Scholars Press, which is in its second edition. That's not a self-published like my books, and I think Bill's books too. It's his writing is very clear too. It's easy to understand. I can't remember.
What is the actual mechanism then, if it's that clear?
Well, I haven't read his book yet. I've read parts of it, and I'm working on other things right now. I've only got so much time. But his name is Andre, Andre, Michaux, Michaud, and he has his own toy company, scientific toy company. See if I can find it here on my wall, the address. Just a minute, I'll be right back. I can find it.
So while you're looking for that, one interesting thing to look at would be, I mean, the special theory of relativity says it's time dilation, time itself dilates, and therefore any type of time measuring device would show these effects. But it would be interesting to see whether if you put in some other types of clocks, either conventional or maybe new type developments, to see whether it was atomic clocks fundamentally showed this slowing down or speeding up in these fields, but other clocks didn't. Well, if that were the case, that would obviously disprove time dilation per se.
Yeah,
but I don't think
yeah,
any
here's the
experiments
book.
have been done yet.
Here, I've got the book right here. If you, Scholars Press. Let's see here. Oh, I better read it.
A little bit higher.
Electromagnetic Mechanics of Elementary Particles, Andre Michel.
Well, it's interesting. So Ian brings up the question about if you put other clocks. But I think the problem is that these effects are so small that only extremely precise atomic clocks can show the tiny differences that are right there. But you know, it's kind of an interesting question that if I just stuck my my wristwatch there, and would you see the time dilation effects? Actually, I think I do recall someone actually doing something like that, where they like pasted their digital wristwatch on the front of their car and drove it around and compared it against the digital watch that was stationary. And I think that if you can account for the drift of the watches, then you can actually get a fairly precise measurement. I think. I mean, I was hearing something about that you could try and use something like that, but or like if you had like a grandfather clock with this big swinging pendulum, would that also be affected by these time dilation effects? In the emails, you know, people are proposing mechanisms by which the cesium atom, the cycles per second get altered because there's like perhaps gravity is some kind of flow or something, and it's that flow which is changing the frequency. I did not personally find that to be very convincing myself. In my research on this particular subject, I was surprised to find that at the heart of every atomic clock is actually a quartz crystal, the same one that is in our digital wristwatch. So what it's actually counting is not the cycles per second of the cesium atom transitioning between there. Now, I don't fully understand how an atomic clock works. What I understand is that the atomic part of the clock is just there as a feedback loop, so that if the quartz crystal slows down any, then the atomic part of the clock causes it to speed back up. Because effectively, to my understanding, the way a quartz crystal works is that it receives a periodic ping of energy to keep it running, and it's that the rate of ping is being controlled by the atomic part of the clock as just a feedback loops. So essentially, it's not really detecting the difference in the cycles per second of the cesium atom. What it's detecting is still just the waving of the quartz crystal through space. And in that way, it's very much like the spring mechanism inside of a wind-up clock or the pendulum of a grandfather clock. So we still have something macroscopically large going through space. So rather than we're looking for an actual change in the actual transition speed. My personal opinion is that if you actually had a clock that was actually based on the transitions, the actual transition, that I would feel that that clock should actually be completely immune to these relativistic effects, because that should happen at an absolute constant rate. And,
Ron Hatch in his paper on A New Theory of Gravity, 2007, Physics Essays, deals with the pendulum clock, and you might be interested in his conclusions.
Well, possibly. I'm only interested in saying pendulum clock because it's a mechanical system that's a lot easier to understand. If you have a big mechanical arm that's making its way through space, and then you can see that if you put something different in the case there, so instead of water, let's say instead of air, you put water, and water is much thicker, and then that would slow down the clock, right? Or you put molasses in, that would slow it down even further, right?
Yes, that's right. But
so
and what were Hatch's conclusions? Perhaps you could remind us of them in that 2007 paper.
All I can remember at the moment is that he distinguished between pendulum clocks and spring clocks and clocks like that, because pendulum clocks depend on gravity. And also he claimed that inertial mass and gravitational mass were not equal, as Einstein stated in the equivalence principle. So he has his own inertial mass and his own gravitational mass, which need not be equal. I wish I could remember more, but his paper is in Physics Essays, 2007, I believe, and it's a long title, but it starts out with A New Theory of Gravity.
Thank you.
Now, do you remember what was Ron Hatch's conception of gravity? Do you remember what the main thing was?
I think, no, I can't honestly. It all depends on gravitational mass. And he had a formula for gravitational mass in his paper, equation 16 through 18 or something like that. I could have those numbers, could be wrong, and he also had an equation for inertial mass, which and the two did not necessarily agree, which is why he rejected Einstein's general relativity.
Well, I always have a question about when people say reject relativity. It's kind of hard to figure out exactly what they're rejecting. If you just look at
he was rejecting the equivalence principle, the elevator experiment. He rejected that because his calculations showed that inertial mass did not necessarily equal gravitational mass, so therefore the elevator experiment idea was wrong.
Well, I don't know that that's been experimentally demonstrated, that gravitational and inertial mass are different. I think that's probably one of the most carefully confirmed things in
this book by Professor Dmitriev. In this book by Professor Dmitriev, he shows clearly that gravitational mass is not equal to inertial mass, experimentally.
Well, wasn't that the one? I understand that gravitational mass can differ according to things like temperature.
Yeah.
Right.
Also,
but that doesn't.
Rotation.
And rotation, but that's
a rotating object whose axis of spin is parallel to the surface of the Earth, then it falls at a different rate depending on its RPM.
Yeah, that I can understand, but that does not really address the whole inertial versus gravitational equivalence mass thing.
Well, I have a paper on gravitational inertial mass on my, it's on academia.edu and also researchgate.com, which can be freely downloaded on either site.
Although I think the equivalence of gravitation and inertial mass is generally done by showing that all objects, irrespective of their composition, fall at the same rate.
Yes, well, they do, provided that they're not rotating. If they're rotating, they fall at a different rate. in general.
It might be, but they would still be, under the same circumstances, still equivalent. I'm just saying that that doesn't really prove that inertial and gravity are non-proportional to each other. In
Well,
that
it
case,
does,
I mean,
though.
just no, I don't think so.
Because-
That just says that the gravitational mass can be variable. Of course, it can still be
but
proportional
if
to inertia.
gravitational mass is equal to inertial mass, and if gravitational mass is variable, then inertial mass is variable.
Yeah, and inertial mass probably varies as well.
Yeah, but
But you have
inertial
to have an
mass.
experiment to actually show that.
Yeah, he's got. I'll tell you what the title of his paper is here.
So in order to prove that, you'd have to take your spinning ball and then exert a force on it, and then show
Well, the
that
force is
even
gravity.
that force is either the same or has been reduced by the spinning action. I don't think that experiment has been done. But it's interesting that
experimental confirmation of the gravitational force negative temperature dependence. That's not predicted by the elevator experiment. And
no, that
here's
is something
one:
completely
frequency
different.
dependence of a rotor's free-falling acceleration and inequality of gravitational and inertial mass. Alexander L. Dmitriev, AR capital XIV colon 1101 period, or possibly a comma, 4678, General Physics, 2011.
Well, that's something we can look at there. But this is, once again, one of those questions where we can observe things. If you look at the equations of general relativity, I think those are probably well confirmed. So are
Well,
we?
they're mathematically correct. They're not physically correct.
Well, what do we mean by physically correct? I mean, what exactly are we talking about here?
Well, the elevator experiment is the basis of Einstein's general relativity theory, which says that what you can either have an elevator accelerating at minus 9.806 meters per second squared, or you can just hold this elevator steady and watch the thing drop at 9.806 meters per second squared, and you get the same answer either way. But that's not true, because if it's rotating, it falls at a different velocity. So the elevator experiment is just the wrong idea.
I'm not sure if I would agree with that. I mean, it's almost like a different tangent, I would say, but I haven't thought about it too much myself.
All right, okay, sure.
But the fundamental thing we're trying to figure out here is, what is the cause of the slowing or the change in the clock, and it's been suggested that, well, maybe it only applies to atomic clocks. Maybe it depends on the type of clock.
The only one's accurate enough. The other clocks aren't accurate enough.
Yeah, the other clocks are accurate enough. Oh, they did point out that a non-atomic clock, as simple as a common wristwatch, can be accurate enough, given that if you accounted for the drift of the watch. At least I saw something about that. So,
and if your analysis, earlier description of the basic quartz element is correct, well then anything presumably controlled by a quartz would show this effect. It's not the atomic element per se, according to your own description.
Yeah, that's what I was thinking, is that it more has to do with the physical waving or the resonance of that crystal, which is a macroscopic thing. You can put it under a microscope and you can see it, right? Looks like a tuning fork. That is a thing which is actually vulnerable to the time dilation. Versus if you built a clock that actually depended on the cycles per second of the cesium atom, that if you were actually built a clock out of that, and I would like to see someone build a clock like that, and I've heard, maybe read some articles about maybe people trying to build atomic clocks like that, which don't have the quartz crystal in them, that I think my prediction would be that you would find that clock would be immune to these relativistic effects. And then that would go to what I postulate, which is that that time itself is quantized, that it is running at a constant rate throughout the universe, and that specifically clocks based on the actual transitions of an electron that generates, say, the spectra. So you have a hydrogen atom and you excite it. We know that the electron is going through different states, like from 2 to 3 or 2 to 4 or from 1 to 2. If you had a clock which is based on just the speed at which an electron can jump from 1 to 2, that would have to represent the absolute master clock of the universe, at least in my hypothesis. And then that would be completely invariant no matter what gravity field you were in or how fast the clock was moving. So I'm just hoping that someone actually invents a clock like that, and we might be able to confirm the absolute quantization of at least time. Because I think some people have been mentioning about time dilation, and I think it's important to note that only applies to the specific clock you're looking at. And what's happening is not actually a changing of time, but it's a slowing or speeding up of the mechanism of the clock. That speed time in general in the whole universe does not slow down just because there's one clock that's in a rocket that's going very fast. Only that clock that's in the rocket is the thing which is showing less time than the clock that was sitting on Earth, but in no way has the passage of time changed in any absolute sense. It's just something you read on our mechanisms, I would say. So I think that's a clarification. But it looks like we're getting towards the end of our chat here today. So I think thank everyone for participating. I think we started out the discussion with kind of a question about, if we're so advanced, it's February 2020, then how do we still not know anything about things like how gravity works, right? Not even amongst the mainstream do they know. So we're kind of questioning why that might be. I think Bill said that perhaps maybe the answers may have something to do with religion, although if the answer just comes back to it's God, then I'm not sure how that helps us either, right? So I'm not terribly convinced that that's the direction to go. I would prefer to be that science is working its way towards as physics, a physical solution. That's always been kind of my shtick. So I would prefer to not refer back to God, not because I don't like God, I love God and all that stuff, believe in him, but that I don't believe that God wants to be responsible for every little atom in the universe. So I would prefer that come up with the answer that said that, well, God came up with just a very simple system. He invented just these particles and everything else emerges out of that. But that's one possibility that all these factions may be responsible for kind of limiting what thoughts are going on. And then we also discussed that there's just the orthodoxy that's out there. And even if we became the orthodoxy, then we would probably be just as bad, and we'd still be in the same wrong boat as everybody else. So and then finally we kind of got into a little bit about specific questions about relativity and time dilation. But I think that'll do it for this week's episode, and hopefully I'll see you back next week. And if anyone else is watching this on the live stream, I see we have 17 people. Thank you for showing up and watching. Please tell your friends, and they can come here and participate in our little chat here and talk about anything you like. All right, goodbye.